So hello friends, myself Madhyadeep studying in Sri Venkateshwara College of Engineering, Bangalore. Today my videos are about understanding standard errors in statistics, which is a topic from mathematics for CSE stream, second year, third semester. So let's go into the video. So the concept of standard error sits at the heart of the statistical analysis, offering insight into the precision of our estimation from sample data. So it is a critical tool for statisticians, researchers, and data analytics who aim to infer the characteristics of a broad population based on a subset of observations. So, by grasping the nuance of standard errors, one can navigate the realm of probability and make assistive conclusions backed by robust mathematical principles. So, a close look at standard errors. So, the standard errors AC measures reflects a dispersion of sample mean around the true population mean. So this variance is inevitable due to random nature of sampling. So yet understanding it is pivotal for accurate statistical interference. So one must not confuse standard error with standard deviation. So while the latter measures the variability of individual data points with a sample, so the former concern the means of different sample drawn from the same population and the sample variance, population insight, and measuring precisions. So each sample mean may differ slightly due to the sample's unique composition, which is highlighted by the standard errors. So the population mean, while generally unknown, is estimated more precisely when the standard error is minimized. So measuring precisions, so standard errors act as a thermometer for reliability of sample means approximation of population mean. So decoding the standard errors. So the formula for standard errors is elegantly consists, yes, yet it holds the height of slightly significant statistical principle SC is equal to rho by root over n is underpinned by two fundamental parts. So the population standard deviation rho, including overall data variability and the sample size n, implementing the size of the data set at hand. So this quotient reflects the inverse relationship between sample size and variability. Increasing the number of observations typically leads to more stable estimate of population parameters. So the first one is population standard deviation rho. The rho symbolizes the extent to which data points diverges from population mean integral to computing SC. Second one is square root of sample size. Root over n. So where n is the sample size, the square root of the sample size denotes the rate of reduction in errors as more data is collected. The third one is division result. So dividing the row by root over n yields the standard errors, highlighting how additional data improves the estimate. So interpreting standard errors in practice. So Nanon expectation of standard errors extends beyond its definition to its practical implementations in the realm of statistics. It serves as an indicator of how well the sample mean will match the actual population mean. So in statistical practice, this understanding can dictate the confidence we have in the result obtained from our analysis. So great precision. The small values of standard error significantly are sample mean that is more likely to hover close to the population mean, thus increases the precision. The high variability. So high standard error value hint at a diverse set of sample means indicate the sample may not represent the population efficiently. And standard errors is constructing confidence intervals. So when constructing confidence intervals, standard errors serves as a keystone. So these intervals provide a range in which we believe the population parameters, example, the mean, lie. So for instance, 95% of confidence interval suggests that there is a 95% probability that the interval contains the population mean. The sample estimate. So calculate the sample mean, which serves as the center of the confidence interval. So margin of errors. So using the standard error, multiply by a Z score like 1.96 for 95% confidence to define the margin of errors. Then interval construction. So create the interval by adding and subtracting the margin of error from the sample. So actual example, the student test score. To consider the example of 100 students, test scores who were leveled in the applications of standard errors to reduce a confidence interval. So the standard errors formula returns life into a numbers, shaping them into an incredible narrative of what we can expect from the population's performance. So here the low standard error signifies a tight clustering of sample mean around the population mean, allowing us to state with high confidence that the average test score for all students is reliable close to our sample mean score. So 70 mean score. So this is the average test score of out of 100 student sample, one standard error. So calculate using the formula with a population deviation of 10 and the sample size of 100. So calculating the confident intervals. So the competitive of confident intervals is more than mathematically acrobatics. Acrobatics. So it's a testament to power of standard errors in claiming our statistical prospections. We are with a known degree of certainly established the boundaries with which the true average lies. So the interval one abstract now has tangible around bounded with which vividly illustrate the concept through a concrete example. And the first one is lower limit. So the lower boundary of the 95% confidence interval is calculated using the sample mean minus the margin of errors. And the second one is upper limit. So the upper boundary is found by adding the margin of error to the sample mean, rounding out the intervals. So summary. So empowering statistics with standard errors. So in sum, so standard errors is not only a calculation but a lighthouse guiding statisticians through the fog of sampling variability. So by equating research with the methods to estimate and interpret standard errors, we empower them to make more precise predictions and sound decisions based on statistical data. So when so whether used to bolster the Vedic of an experiment, survey, or study, standard error embroids the essence of inferential statistics and remains an invaluable instrument in the art of deducing population traits from sample. The first one is score measure. So standard error remains essential in evaluating the speed of the sample and thereby the accuracy of statistical inference. The second one is confident crafting. So it is the underpinning in the crafting of confidence interval, which reassures the reliability of the samples representing of the population. And the third one is statistical tools. A crucial statistic tool, it addresses the probabilistic nature of sampling, setting the foundation for empirical research. So thank you for watching this video.